Okay, all of these are from 5.1 on the pre-calculus textbook. We're trying to verify trigonometric identities. Do you agree with the following? Sine squared plus cosine squared equals 1. Okay, can I solve this for cosine squared? If I subtract sine squared from both sides, what will cosine squared equal? 1 minus sine squared. Does everybody agree? So what can I replace this cosine squared with? 1 minus sine squared. Minus sine squared minus another sine squared is minus 2 sine squared. And there I have it matching the answer in 9. Okay, I'm going to try and do them kind of in order. After 9, I think I was 17 was the next biggest one. So, I don't know. If all fails, break everything into sines and cosines. Sine is simply sine. Tangent, however, is what? Sine over cosine. When you multiply the tops, you get sine squared. You multiply the bottoms, you get cosine. One more time, do we know what sine squared could be called? Perfect. Sine squared could be called 1 minus cosine squared. Sine squared could be called 1 minus cosine squared. So the top I'm going to call this. And it's divided by x, and I think that that now matches what I wanted it to. No, you're right, it's not just x in the bottom, it's cosine of x, so you're absolutely right. Okay, we have 17 done. Now we're going to move to, I think, 29. So we have 1 minus sine squared x divided by 1 plus cosine x. If I wanted to add or subtract fractions, you would need a what? Common denominator. Can 1 be called 1 plus cosine over 1 plus cosine? That anything divided by itself is 1, is it not? So what do I now have in the numerator? I have 1 plus cosine minus sine squared, and this is all divided by 1 plus cosine. Again, if you're really bad in algebra, you might make some mistakes, but this is subtracted. You can't cancel it. It's not multiplied on top. Let's see what we could do some replacements with. I have 1 plus cosine. It's divided by that, but there's more to it. You still have minus. What might I replace sine squared with? Because whenever you subtract, you use parentheses. Could sine squared be 1 minus cosine squared, as we found on the previous problems? Hopefully it is. So let's clean this top up. 1 plus cosine minus 1 plus cosine squared. 1 and negative 1 will add to 0, leaving me cosine plus cosine squared. Can you factor anything out of those? Can you take a cosine out? If you take a cosine out, you'd have 1 plus cosine as a factor, which means multiplied, which allows it to cancel with the 1 plus cosine of x on the bottom, or divide out, and that leaves me with my answer of cosine of x, right? So hopefully this matches what I was trying to show it equaled. Okay, there are usually more than one approach to get to the right answer. So if you'll bear with me, I'm going to try a different approach. Hopefully we'll get the same answer. Let's see what happens. cosine of x, that's a 1. So you have 1 and then cosine of x. Now, what could sine squared be called? I think it could be called 1 minus cosine squared. Does that factor into the difference of squares? 1 plus cosine times 1 minus cosine. And what's going to cancel? The 1 plus cosines, because they are now factors, top and bottom. So now you have 1 minus cosine. When you distribute your negative, 1 minus 1 plus cosine simply becomes cosine. So perhaps that's an easier approach. I'm not sure. There are multiple approaches. Okay, 29. I was also asked 35, 43, 27, 37, 51, and we did 9. So it looks like 27 might be the next one sequentially. What do you need to add fractions? You need a common denominator. So I'm going to write this as a fraction, and tangent is sine over cosine. What would be your common denominator? Well, you can always get it by multiplying the denominators. So cosine of x times 1 plus sine of x. So my common denominator is going to be cosine of x times 1 plus sine of x. There's a plus here. I have my desired denominator. What do I need on this side to make the denominator that I need? You have a cosine. What don't you have? 1 plus sine. So that's going to be something divided by itself, so it's a fancy form of 1, and you're not changing the values. So what does this make this? What's sine of x times 1? Sine of x. What's sine of x times sine of x? Sine squared of x. Any questions on the left-hand side?
Yeah, where did you pull the 1?
So that's the left in yellow. On the right, I have the 1 plus sine, but I need the cosine. So you might multiply again by a fancy form of 1 so you don't change the value. And that becomes cosine squared. Okay, so I have sine of x plus all over cosine x times 1 plus sine of x. And what do I have if I have sine squared plus cosine squared? That will always equal 1. Because addition is commutative, you could cancel these, leaving me 1 over cosine, better known as secant. And I believe now that this matches what I need it to equal. Okay, let's see what we have here. We did 9, we did 17, we did 27. So the next biggest number would be 35. So let's look at this one. I'm going to suggest you break everything into sines and cosines. Secant is 1 over cosine. Cosecant is 1 over sine. On the bottom or in the denominator, secant is 1 over cosine. And this is plus, and cosecant is 1 over sine. In the numerator, you need a common denominator. What would it be? Cosine times sine or sine times cosine, right? There's a minus. This one needs what? I believe it needs a sine. And when you multiply the top, I think you get a sine of x. On the right over here, you need a what? Sine cosine. So here you're going to need to multiply by cosine. Then I would have this denominator. Any questions so far? Only been working on the top of the fraction. What's a common denominator in the denominator here? Cosine times sine or sine times cosine. So your denominator is going to be sine times cosine. This time there's a plus between them. What do you need on the left here? You have cosine, you need a sine. Sine times 1 makes sine. What do you need on the right over here? Cosine. Now I'd have a common denominator. So I'm just going to rewrite this at the moment, at least the top part. So you have sine minus cosine all divided by, let me write it over here because I need a little more room. So I have sine of x minus cosine of x all divided by this part here, which is sine of x times cosine of x. How do you divide by this fraction? Well, you multiply by the reciprocal. So this becomes sine x cosine x all over what? Sine x plus cosine x. And let's see. Well, you can't cross multiply unless you have two fractions equal to each other. You could cross cancel. We can cross cancel like this. This makes sine of x minus cosine of x divided by sine of x plus cosine of x. Now I might do some more manipulations on it here in a moment, but so we're on our way. So what I'm going to do is bring it up over here, and we're going to write sine x minus cosine x divided by sine x plus cosine x. A lot of people are going to struggle here, but I'm going to multiply by the conjugate of the denominator. The conjugate of a minus b, the conjugate of a, what happened? The conjugate of a plus b is a minus b. When you multiply those, you'll get a squared minus b squared. So, let's go back to here. What's a? I want to multiply by its conjugate, so instead of sine plus, I want sine minus cosine. And again, it has to be a fancy form of 1. What do you get on the bottom? What's a plus b times a minus b? A squared minus b squared. So if this is sine, a is sine, what's a squared? Sine squared. Now this is in the, what, the denominator? So I want to make sure I put it in the denominator. That would be sine squared minus what? Cosine squared, because this is the b, right? And I need b squared. What do I have on top? Do I have sine plus, no, sine minus cosine times sine minus cosine, or sine minus cosine quantity squared? So we're going to clean this up a little bit further. I'm going to erase some to see what we can do with this. I need to make a little room. So bring this up. If I square that, does that mean times itself? Sine x minus cosine times sine x minus cosine of x. And how does a bottom factor as the difference of squares? Sine x plus cosine and sine x minus cosine. But I don't see where I'm getting anywhere with this. It seems these will, the minuses would cancel, right? So what am I left here now with? Sine x minus cosine x all over sine x plus cosine x. And I bet I had that earlier. I was going to say, I think I worked completely around in a circle. I may have to come back and look at this one. Perhaps I'd be better off working on the right side of the equation instead of the left. But the point is, I'm going to abandon one approach and try another approach because I'm willing to do so. And the question or point is, will you be willing to do that? If you run into a dead end like I just did, are you willing to abandon that approach and try a different approach? I hope so, because that's called tenacity, when you can stick to it. Like I was saying, you're absolutely right. This is equivalent to what we had. What I had to do, however, was I had to manipulate the right side a little bit to get some equivalent statement to what I had. No, that's fine. I'll accept it that way. It's just that there's, for the most part, we want to try to work only on one side of the equation. I'll have to admit, there's times I have to work on both sides to show equivalence. Okay, this is 37, significantly easier than the previous one. This is a squared minus b squared. That'll factor into a plus b times a minus b. In other words, the difference of squares. So this will be sine x plus cosine of x times sine x minus cosine of x. It's all divided by sine x plus cosine of x. These two could divide out, leaving me the answer that they want us to get. Hopefully this matches what we started, or what we wanted to. It's not, so we want 1 minus cosine. I believe I wrote this wrong. I think this should say sine minus cosine. Let me check. This is correct, and that's the way it's supposed to be. 37 was asked. Let's see if I got any before here. We've done 17. We did 29. We did 35. We're going to 43. So I'm going to change everything to sines and cosines. You're welcome. Tangent should be sine over cosine. Tangent should be sine over cosine, but these are y's, right? And what is it divided by? 1 minus tangent, which is sine over cosine, times tangent, which is sine over cosine, but this time they are y's. Now I'm going to put them together, top and bottom, separately. Okay, I need to get a common denominator in the numerator. So between those, you can always get a common denominator by multiplying. So my common denominator is going to be cosine x cosine y, correct? So I make my denominator to be cosine x times cosine y. Now, if I want cosine x cosine y, this needs which one? Cosine y. So what would you have on top here? Sine of x times the cosine of y, right? Then you have a minus. I made a common denominator on top. This has a cosine y. It needs a cosine of x, right? So I'm going to multiply by cosine x over cosine of x, leaving me what on top? Cosine of x times the sine of y, right? Which we know might be taking us somewhere because that matches. It is a plus in the middle, correct? And so we know we're getting close because it does match the numerator. Now, in the denominator, we need a common denominator. You can always get it by multiplying those. So it would be cosine x cosine y again. Cosine x cosine y. I notice that this is already over that. So sine x sine y is right here. This 1, let me use a different color here. Could this 1 be written as cosine x cosine y divided by cosine x cosine y? Is 1 anything divided by itself? Yes. So what that enables me to do is to replace the 1 with cosine x cosine y divided by cosine x cosine y. Now, if you're from Pioneer Middle, you might have learned this as stay, change, flip. If you learned it from me, if you divide by a fraction, you multiply by the reciprocal, correct? Cosine x sine y. This is divided by cosine x cosine y. So what I'm saying is, if I'm dividing by this, does that mean I multiply by the reciprocal? So that would be cosine x cosine y, which very conveniently will eliminate each other. Cosine x cosine y minus sine x sine y. So now I think we could cross cancel, not cross multiply. Now top times top would give me what? Sine x cosine y plus cosine x sine of y, all divided by this, right? Which is cosine x cosine y minus sine x sine y. At this point, I think this matches what we were trying to make it look like. This is a little more challenging because you have a bunch of fractions to add with common denominators. I'm going to attempt a slightly different approach to the same problem, but I need some room. So I'm going to erase this, this, and all this. And this is sine of y, right? And I'd like to get rid of this and this. Okay, at this point, we had a common denominator of cosine x cosine y, right? And this needed what? Cosine y? Didn't it? It needed cosine y over cosine y. So that was sine x cosine y. There is a plus. This needed what? Has cosine y, it needs a cosine of x. So that gave me cosine of x times sine of y. Divided by, now again, I don't see any other way other than making sure you have a common denominator. If you want, I can leave it as 1 minus sine x sine y divided by cosine x cosine y. What are my denominators? Cosine x, cosine y? So what I believe you're saying, and I think it's right, is I could multiply by a fancy form of 1 here. And when I do that, on top, those cancel, right? Leaving me sine x cosine y plus cosine x sine of y. When I multiply here, what do these give me? What's 1 times anything? Itself, so it's cosine x cosine y minus, and when you multiply here, do these cancel? Leaving you sine x sine y. It's pretty much just the same thing we did, but it does match the answer. Okay, so we've done 17, 29, 35, 43, a few ways, 27. Let's take a look at 37. We did 37? We all right? We did 37? Factor the top, difference of squares, it cancels and leaves you this, right? Okay, now we're going to do 51, and we'll come back for any new. Okay, we're going to try 51. I see this as a difference of squares, so this could be called sine squared x minus cosine squared x. Actually, one is plus and one is minus. Cosine squared minus sine squared. Let's see what we can do with this. I'm not just going to distribute it, because if I did, it would just bring me back to where I started with, and I'd be working in a big circle. No, you're absolutely right. The order does matter. So it's not cosine squared, but what should be first?
So in the textbook, it's cosine to the fourth of x minus sine to the fourth.
So you're saying I wrote down the original problem wrong?
Yes.
Let me check that. Okay, apparently I wrote down number 52, not number 51. So 52, tell me if I'm wrong, says cosine to the fourth minus sine to the fourth. Does that look better?
Yes.
And then it equals 1 minus sine, 2 sine squared. So this would equal 1 minus 2 sine squared. Again, let's factor this as a difference of squares. We'd have cosine squared plus, and we would have cosine squared minus sine squared and sine squared, right? Well, what is cosine squared plus sine squared? So really, this is all that I have left, right? Because what is this times 1? It's itself, cosine squared minus sine squared. Now, I'm hoping after extensive work on this that you're going to know that sine squared plus cosine squared equals 1. If I subtracted one of these, such as sine squared, what could cosine squared be called? 1 minus sine squared. So I'm going to replace this with 1 minus sine squared. Minus sine squared minus another sine squared is minus 2 sine squared. And hopefully that now matches what I need it to equal. Now 52 that I had written down before was almost identical. You might want to try that. Okay, that would be 51. We've done 9 and we did 37. So let's see if I can pry some more questions out of the audience. Okay, I was asked number 19, so let's see what we can do with this thing. There are lots of options. I usually change everything into sines and cosines. Cosecant squared is 1 over sine, and because it's squared, it's 1 over sine squared. Divided by cotangent. Cotangent is cosine divided by sine. You're going to stay, change, flip. Or, when you divide by a fraction, you multiply by the reciprocal. One of these signs will cancel, and that'll leave me with 1 over sine times cosine. That's 1 over sine times 1 over cosine. 1 over sine is cosecant. 1 over cosine is secant. And I believe that matches the answer that we want. So 19, I rewrote cosecant as 1 over sine, and it's squared. That's right here. Cotangent, I wrote as cosine over sine. Stay, change, flip, multiply by the reciprocal, re-express it, you get cosecant times secant. Now 45 I was asked, right? Let me see if it's in order. Let's go 45, why not? See what we can get. We can work on the left or the right. I tend to work on the left. So secant is what? 1 over, well, do you want to square it first or not? I don't know. Secant is 1 over cosine minus tangent, which is what? Sine over cosine. Do you already have a common denominator? So you have 1 minus sine divided by what? Cosine. That means you square the top, right? So it'd be 1 minus sine x quantity squared divided by the bottom. And that would also be squared because you're squaring the whole fraction, right? Now, 1 minus sine squared is 1 plus sine times 1 minus sine. What could you call cosine squared?
Wouldn't it be 1 minus sine?
Where am I? Oh, yeah, they're the same. You're absolutely right. It's squared, so they would be the same. Cosine squared, what could it be called? 1 minus sine squared?
Or 1 minus sine.
Right. 1 minus sine squared, which you're right, 1 minus sine squared could then factor into 1 plus cosine, 1 plus cosine times, let me write it out because I'm confusing myself. Do you agree that this right here could be 1 minus sine squared? And that would factor into 1 plus sine and 1 minus sine, right? Then these could divide out, and hopefully what remains is what we're trying to find. Does that match this? Looks like it does. So that was 45. I changed everything into sines and cosines. Then I squared wrote it as a single fraction, squared. Squared the top, squared the bottom. Realized that cosine squared was the same as 1 minus sine squared. Then 1 minus sine squared would factor into 1 plus and 1 minus sine. Those would cancel, leaving me my result. And let's look at finally 39. I have tangent squared of 2x plus, does anybody know the most important trig identity of all? Sine squared plus cosine squared, as long as the angles are the same, is going to equal 1. Do you agree with that? So that's 1 plus tangent squared. There's an identity that 1 plus tangent squared equals secant squared. And I'm sorry, I lost my angle. It's not just x. The angle is what? 2x. So anyway, I hope I have it matching the answer that we need. Do you know your 3 Pythagoreans? You should know that sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cosecant squared equals cotangent squared. So you use these Pythagorean identities fairly extensively sometimes. I hope these help. Good luck.